Okay, good morning, fourth graders. It's Thursday, April 23rd. I had to look over at the calendar. And this is going to be our math lesson for today. Again, we're working with adding angles or angle measurements. And this time we're working with field of vision. So what they're showing you, it says the area that you can see, and this is page 274 in your math journal. I should tell you that first. So it's the very next page in your math journal. We did 273 yesterday. We're going to do 274 today. And we will probably do 275 because I think it's kind of a cool lesson to do. So taking a look at this, it says the area that you can see without turning your head is called your field of vision. The area outside of the field of vision is the blind area. Look at the diagrams below to see the field of vision for different animals. So like as a human, your field of vision, if you take your fingers and put them out front of you, your field of vision is as far as you can see your fingers. Like I can see that one wiggling. About that's my field of vision. So if I turn this way, you can see, I can see something coming at me from these angles without having to turn my head. And this is important in the wild because if you look at like a human can see about 180 degrees. We can see anything coming from the sides of us, but from behind you can't really see. Owls, same thing. You can see out, they don't have a very wide field of vision, but a rat is something that gets eaten in the wild, so it's got to have a little bit bigger field of vision. It can see things coming kind of from behind it, where you can see if something came, if you look at this, there's that line. That line over here is probably right there. So a predator, a human, we don't have a whole lot of predators, but a rat's going to be able to see a predator better than, say, a human. Owls don't really have predators too much. They are a predator, but the thing to remember is these are always a circle. Your field of vision is always a full circle. I know that's not a perfect circle. I'm drawing it freehand, but for all of these, it's a circle. So today, for all of these fields of vision, they should always equal, field of vision plus blind area should always equal 360 degrees. So, in this table, the first one, it's a human. So, we have a field of vision of 180 degrees. To figure out our blind area, you've got to take 360 and subtract 180. Okay, I'm going to do the first one with you here. 0 minus 0 is 0. Cross out that 3, make it a 2. This becomes 16. 16 minus 8 is 8. And 2 minus 1 is 1. So our blind area is also 180. And that makes sense if you look back. This is going to mess up where the answer is. But if you look, this is half of the circle, right? So 180 plus 180 is going to get you 360. So now, pretty easy math to do. The fox has 260 degree field of vision. So that means you've got to take and subtract that from 360. So go ahead and do that. Okay. 0 minus 0 is 0, 6 minus 0 is 0, and 3 minus 2 is 1. And that makes sense because 260 plus 100 is 360. So if you look, the fox has less of a blind area than the human. Well, the fox is a predator. The fox eats mice and things like that. The fox also might get eaten by like a coyote, or there are different things that could probably catch and eat a hawk. So foxes kind of have to be careful too. A horse, boy, this one, think about this. It might be just as easy to add up. But look at the field of vision for a horse. A horse can see 357 degrees. So how big is its blind area? And if I was doing this, I would just think to myself, I'm at 357, I need 3 more. Well, if you think about that from in the context of a circle, that means that a horse, if a horse is facing, I'm not a great drawer of horses, but there's my horse's head, okay? Looks more like a cow maybe. Maybe if I give it a mane. There you go. Now it looks maybe more like a horse. Horse's eyes sit right here. And horses can see, this is a horse, it can see pretty much everything except for a little bit right here. Cows are kind of the same way. And that's why you should never, ever, ever walk up directly behind a horse, because that's the one place that they can't see you. You should always try and come, like even I probably wouldn't come from that direction, but you should always try and come from their side so that they can see you. Because even if it's your pet horse, if you come right up behind you, at least this is something that I was taught by my aunt who owned horses, if you come up right behind them like that, it might startle them because they don't see you. But if they see you and they know you, they're not going to be so startled. Okay, now this is kind of the same type of process. The cat has a blind area of 160. But still, whatever this is, plus that should equal 360. So if you go the other way, 360 minus that should equal this. I want you to do those four on your own. Okay? Let me see what we got down below. I don't think there's any. Yeah, I want you to do those four on your own. Cat, dog, owl, and deer. Go ahead and pause me, and then I'll work through those with you, okay? So hopefully you pause me and you solve those. We're going to work on these four together. For the cat, 360 minus 160. That's a pretty easy problem. 0 minus 0 is 0, 6 minus 6 is 0, and 3 minus 1 is 2. So you should have got 200 degrees of vision for the cat. A dog only has a blind area of 120, so that's like 360 minus 120. 0 minus 0 is 0, 6 minus 2 is 4, and 3 minus 1 is 2. So a dog can see 240 degrees. Owls, 360 minus 110. You guys haven't even had to regroup. This is way too easy for you guys. 0 and 0 is 0, 6 and 1 is 5, 3 minus 1 is 2. Owls have a blind spot of 250 degrees. So you'd have an easy time, well, owls maybe have other senses that maybe I'm not considering, but if it was silent, if you were quiet, you'd have an easy chance of sneaking up on an owl. If you came from a way it wasn't looking. But if you ever watch an owl, owls are constantly moving their heads, so that's how they have very keen eyesight. Deer, 270 minus 90. Finally, you have to regroup. 0 minus 0 is 0. Cross out the 2, make it a 1. This becomes 17. 17 minus 9 is 8. And 1 minus 0 is 1. So a deer can see 180 degrees. And that would make sense. I didn't do that right. Oh, what am I doing? I'm sorry. That's a terrible mistake on my part. It's 360 minus 90. I don't know what I was thinking, guys. I'm sorry. 0 minus 0 is 0. Cross out the 3, make it a 2. Make that 16. 16 minus 9 is going to be 7. And 2 minus 0 is 2. So they can actually see 270. I didn't think that sounded right because deer have a wide field of vision. Alright, so I think you get the idea behind this. Despite my efforts to confuse you. But now we're going to look at something just a little bit different on 278. So this time, what we're talking about is it says the field of vision of many animals, including people, is divided into a binocular field of vision and 2 monocular fields of vision. In the binocular field of vision, we can see objects with both eyes. Binocular vision helps us see in 3 dimensions and tells us how far away an object is. In the monocular fields of vision, we see things with just one eye. The diagram shows approximate fields of binocular and monocular vision for different animals. So like, if I close my eye, what they're basically telling you is, with just your right eye, you can see this. Just your left eye, you can see this. But binocular vision with both eyes, you can see within this 140 degrees. If you look at a sheep, sheep can see with just their left eye that much. With both eyes, they can see this 62 degree area, and with their right eye, you can see here. Same thing with the fox. We talked about it. Fox have really good field of vision. So, they're telling you that the humans have 180 total field of vision. Well, binocular plus monocular equals total vision. So, what we have here, what I would do is if they give me two of these boxes, I'd add them together. 140 plus 20 is 160. Now, 160 plus something equals 180. You could do that adding up. That's a pretty easy one to add up. Or, if it's easier for you, you could just subtract. And either way you go about it, 0 minus 0 is 0, 8 minus 6 is 2, you're going to get 20. And usually your monocular visions are very similar, or are going to be the same. You can see that 110, 110, 148, 148. But it's still good to check. So if you look at the merino sheep, we have 62, 104. My guess is this is going to be 104, but we can check that. Let's go ahead and check that. If that's correct, this plus this should equal 270. So I'm going to do this first. I can kind of do this in my head. 104 plus 104. 4 plus 4 is 8. Zeros are just going to be 0. 1 plus 1 is 2. So 104 plus 104 is 208. And then I've got 62 more degrees to add. 8 plus 2 is 10. Carry my 10 over. 110 moves over. 1 plus 6 gives me 7 tens, and 2 plus 0 gives me 200. Hey, we did it right. Okay, that's just a taste of that. We're going to work a little bit more on that on Monday. We'll go through more of these. But I want to go over your math boxes. Oh, I wanted to print. We're going to break this down. I'm not going to give you too much for math boxes today. What I want you to do today, here we did letter A. Today I want you to do letter B. And box 2 here, I want you to do C and D. When it comes to box 3, I'm going to have you do C and D again. And we'll save the rest of the math boxes for Monday, because this is a pretty big lesson. So, a little bit smaller math boxes today. And we're drawing this math lesson out because it's a big one, and I want to hit all this stuff. So, just for today, you're doing letter B, C and D in number 2, and C and D in number 3. We'll save C and D in 5, and letter B for Monday. Alright guys, have a great day.